All right, so today we're going to look at lesson 3-1. It's over roots and radical expressions. So a lot of this is review, some of it is new. So pause the video when you get stuck. So let's get through some of the definitions. So for any real numbers a and b, so we're looking at this expression here, and any positive integer n, if a to the n is equal to b, then a is the nth root of b. And so an example of this would be, let's give some real numbers to this. If I had the fifth root of 32, it's asking you what number times itself 5 times will give you 32. So the answer to that is 2. 2 times itself 5 times is 32. Well, another way of writing this or of looking at this would be if we took 2 to the 5th power, that would equal 32. So all we're saying is that a radical is another way of writing an answer to a power. So we just looked at laws of exponents, and we know that 2 raised to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. So basically what it's saying is the 5th root of 32 is equal to 2. So the base of this and the answer of this should be the same. The index here and the exponent here should be the same. The radicand, which is the number underneath the radical here, should be the same as over here. It's just a different way of looking at a radical statement versus a power statement. So for this one, when a number has 2 real roots, the positive root is called the principal root. A radical sign indicates the principal root. The principal root of a negative number a is I times the square root of the absolute value of a. Now, we'll get into imaginary numbers later, so for right now I'm not going to talk about this, but essentially, and this really deals with the principal root of a even root, so because this is a square root. So we'll talk about that later. I wouldn't worry about it now, because that would require a whole lot more explanation. So let's look at the example. The number 25, and this is the purpose of a principal root. The number 25 actually has 2 square roots. Normally, if I asked you for the square root of 25, your answer is going to be 5. Because 5 times 5 is 25. But doesn't negative 5 times negative 5 also equal 25? But because you're used to answering that as the principal roots, it's understood that when I ask you for the square root of 25, that you're going to give me the positive answer. If I wanted the negative answer, there would be a negative out in front of the radical. So then we have to know the parts underneath the radical. So you kind of heard me say it before, but the number underneath the radical sign, that's called the radicand. So over here, in this example, you've got the 2 out in front, the 4 here, which is your root, and then this number 7. So in the radicand in this example is the 7. All right, so then in a radical sign, the index, oops, let me get my pencil here. The index indicates the degree of the root. So over here, the index is this number here, here, and here. So because there's no number there, it's always understood that the index is 2. The cube root of 20, the index is 3. The 4th root of 20, that index is 4. So then let me make this a little smaller so I can get the whole thing in here. So this is just a recap of everything that we've just discussed. Okay. So basically, if I'm taking an odd root of a number, so that's if the index is odd, if I'm taking an odd root of a number, your answer could be positive or negative, because you can take the cube root of negative 8, for instance, and that's negative 2. You can take the cube root of positive 8, and that's positive 2. And the reason for that is if I multiply a negative an odd number of times, so let's go ahead and write an example down. So if I had the cube root of negative 8, I said it was negative 2. That's because negative 2 times negative 2 times negative 2 3 times is still negative 8. It's a possibility. Same thing for the cube root of positive 8 is positive 2, because 2 times 2 times 2 is 8. So the root, the odd root of a positive or a negative number can be positive or negative. But if your index is even, there could be two answers. So like here, there's only one possible answer. Here, there's only one possible answer. But if I had, for instance, the fourth root of 16, what number times itself 4 times gives you 16? Well, that's 2. But that could also be negative 2, because negative 2 times negative 2 times negative 2 times negative 2 is still positive 16. So that's all that it's telling you, is that if n is even, there could be a positive answer and a negative answer. We typically are asking for the principal root, which is just the positive answer. All right, so then here, remember that n is the index. The A here is your radicand. Radicand. And then that symbol is just your radical. All right, so let's look at some real problems with real numbers. So what are the real cube roots of? So we're going to take the cube root of 64. So the cube root of, 0.064, which read correctly, is 64 thousandths. So all you do, and you don't need a calculator for this, all you do is ignore the decimal. Just look at the number. What is the cube root of 64? What number times itself 3 times gives you 64? Well, that would be 4. Then, to figure out the decimal, there are 1, 2, 3 decimal places. However many decimal places there are, you're going to divide that by the index. So 3 decimal places divided by 3 means I have 1 decimal place. So I'm going to put my decimal where there would only be 1 decimal place. I'm going to add a 0 as a placeholder, or not really a placeholder, just so you can see my decimal point. So it's 0.4. So I'm going to do it again, but this time I'm going to do a square root. I'm going to do a square root. So what if I did the square root of 0.0025, so 25 10,000ths. So again, you're going to ignore the decimal and just take the square root of 25. So the square root of 25 is 5. Then count your decimal places, 1, 2, 3, 4. The index here is understood to be 2. So I've got 4 decimal places divided by 2 is 2. So I want 2 decimal places. So I'm going to have a 0 here with a decimal point and then a 0. So my answer is 5/100ths, or 0.05. So that's how you deal with decimals. Then let's look at the next one. So the cube root of negative 125. So what number times itself 3 times gives you 125? Well, that would be 5. And because I have a negative here, my answer has to be negative, because 5 times 5 times 5 is positive, but 3 negatives is going to make a negative. So remember that if you have an odd root and it's negative underneath, your answer is going to be negative. And then we have 1/8. So I'm going to take the cube root of 1/8. So we can split up this cube root and take the cube root of 1 over the cube root of 8. The cube root of 1 is 1, and the cube root of 8 is 2. Okay, look at example 2. So now we're taking fourth roots. So I'm going to take the fourth root of 81. So what number times itself 4 times gives you 81? And that would be 3. 3 times 3 times 3 times 3. You can prime factor it. You'll see that you have 4 3s. Let's use our new theories on here with the fourth root of 16. So fourth root of 16 10,000ths. So again, you're going to ignore the decimal. Just what's the fourth root of 16? What number times itself 4 times gives you 16? That would be 2. Then I have 1, 2, 3, 4 decimal places divided by 4 is 1. So I want just 1 decimal place. So there you go. Then we're going to take the fourth root of negative 16 over 81. Well, that's not possible. You actually can take the fourth root of 16 and the fourth root of 81, but it's negative. You cannot take it. It's understood that we're looking for the principal square root, and furthermore, whether it's a principal square root or not, there is no number times itself 4 times that's going to give you a negative, because you'd have 4 negatives, which makes positive, or 4 positives, which makes a positive. So this is not possible. All right, look at example 3, part A. So we're going to take the cube root of negative 27. I can take the cube root of a negative number, that's okay. So what number times itself 3 times gives you negative 27? Well, it has to be a negative. 3 negatives make a negative. And then 3 times 3 times 3 is 27. So negative 3. Let's look at B before I look at C. So we'll move over here. So we've got the fourth root of negative 81. Can you take an even root of a negative number? No. So that is not possible. All right, you ready to blow your mind? Here we go. So we have C here, which is the square root of negative 7 in parentheses squared, versus D, the square root of negative 49. Okay. Let's look at C the long way. So C technically, and you could argue this 2 ways. This is saying negative 7 times negative 7 is equal you've got negative 7 times itself twice, right? So I could see where you could argue that the answer is negative 7. Because you're like, well, what number times itself twice, because it's a square root, and I've got 2 negative 7s down here, you could argue that the answer is negative 7. Technically, it's asking for a principal square root, right? So we have to take the square root of that, or square root, the absolute value of that, which is 7. Or you could view it this way. The square root of negative 7 squared, well, negative 7 times negative 7 is 49, and the square root of 49 is 7. However you look at it, the answer is 7. Now, let's look at D. The difference between C and D is we have a negative value underneath here. With C, when you did negative 7 times negative 7, it was positive 49. This is negative 49. This is not possible. It's not going to give you a real answer. So not possible. Ponder that for a while. Okay, let's look at 4A. We're going to simplify this. So you got to look at the numbers separately than the power because you've got x to the fourth power, so that's a power. So the square root of 89 is 9. When you find any root of a power, whatever this root is, you're going to divide it into that power. So because this is a square root, you're going to divide that 4 by 2. So 4 divided by 2 is 2, so you get x squared. So let me show you something else. So I could take 81 and change that into 3 to the fourth. Because 3 times 3 times 3 times 3 is 81. And I would have x to the fourth. So I could do the same thing. This is a square root, and 3 to the fourth is the power, so I could divide that by 2 and divide this by 2. 3 to the fourth is, or 4 divided by 2 is 2. 4 divided by 2 is 2, so I get x squared. And 3 squared is 9, x squared. So either way that you look at it, I still get 9x squared. But for powers, you have to take the index and divide it to the exponent. So here I have nothing but variables. So based upon what we just said before, I got to take this index and divide it to the 12 and divide it to the 15. So 12 divided by 3 and 15 divided by 3. So I get 12 divided by 3 is 4, so I get a to the fourth. 15 divided by 3 is 5, so I get b to the fifth. Now, we need to talk about absolute values. So let's go back and look at both of these. So remember, on this particular one, this is an even root. And remember, it's looking for a positive answer. So since I got 9x squared, even if x is negative, when I square it, there's no way I'm going to get a negative answer. So there's no need to use what are called absolute values here. Over here, I'm taking the cube root, and I can have a negative value when I have a cube root, so I don't need absolute values here. However, when you look at C, which is not on this slide, so let's look at the next one. Here's C. So let's look at C. So C is an even root, fourth root. That implies I should have a positive answer. So let's go ahead and take this root and divide it into 12 and 16. So divide, oops, I chose the wrong thing. So divide by 4 and divide by 4. So I get x to the third and y to the fourth. Well, if I want the principal square root here, because it's an even root, then this value has to come out positive and this value has to come out positive. If x were negative, 3 negatives would make a negative. I can't have that. So technically, I need to have absolute values around x cubed. I don't need absolute values around y to the fourth, because if y were negative, 4 negatives makes a positive. So technically, that is my correct answer. So then you're going to have some fairly simple word problems. I'm going to make this smaller so we can see the whole word problem. And really they're just asking you to do some problems involving radicals. So let's read this one. It says, one method for adjusting a student test scores to relate the score to an AP test is to use the formula right here. So that formula is important, so I would circle it. Where A is the adjusted score and B is the raw score. If the raw scores on the test range from 34 to 90, what is the range of the adjusted scores? So we're going to go ahead and use that formula and plug in the values. So we've got 2 different raw scores. We're going to get 2 different adjusted scores. So I'm going to have A equals 10 times the square root of, the first raw score is 34. So you're going to use your calculator and plug in 10 times the square root of 34, which gives you a decimal approximation. So you get about 5.309 on your calculator. This rounds, we're going to round it to the nearest whole number. So it rounds to 58. Then you're going to plug in your second raw score in for R, and your second score was 90. So if you throw that into your calculator, you get another decimal. And so that decimal is 94.868, which rounds to 95. So remember your rounding rules. So if I'm rounding to a whole number, look next door. If this number is 5 or higher, it bumps this one up. Since that's not 5 or higher, it stays 58. Since this is 5 or higher, that bumps up to a 5, so it becomes 95. So therefore, your adjusted scores would fall between 58 and 95. Then we have a couple of sometimes, always, and never questions. So let's read through these. Is each question always, sometimes, or never true, and explain your answer. So is the square root of x to the fourth always going to be x squared? So remember that index there is 2. 4 divided by 2 is 2. So, and this is an even root, so this has to come out to be positive, and there's no way, even if x is negative, for it not to be positive. So this would be always. And the reason is x squared is never negative. All right, let's look at the second one. The square root of x to the sixth. So that's a square root, so we're going to divide that by 2, and we do get x cubed. So I agree we get x cubed, but if x is negative, this is going to come out to be negative, and we want the principal square root because it's an even root. So sometimes this is true. And the reason being is if x is less than 0, it will be false. Then let's look at this one, the cube root of x to the 8th. Well, we're going to take 3 and divide it into 8. You certainly don't get 2. So I would say that this is never, because, let's go ahead and do it. 8 divided by 2, it doesn't, well, that doesn't even look like a 2. 8 divided by 2 does not go in there evenly. So my answer is never. We'll talk about what that answer should be later. All right, last one. If you divide 3 by 3, you get 1. And they put absolute values around here. Well, that's not necessarily true because this is an odd root. You don't need absolute values around an odd root. If x is negative, the answer is going to be negative. If x is positive, the answer is going to be positive. So this is sometimes true. And this is only true if x is greater than 0, then it is true. All right, so if you have any questions on your homework, let me know. Good luck.